Hey, Mr. Yashi coming back at you with 1.3 part 2. So still solving equations with the variable on each side. For example, 4, I have the variable on each side. The variable is p, but we have parentheses and then a number outside the parentheses. So we can distribute both on the left and right sides of the equation. So on the left side of the equation, I want to distribute the 6 to the 4p and the positive 12. So 6 times 4p is 24p. And then 6 times 12, positive 72. On the right side, you distribute the 8 to each term inside the parentheses. So 8 times 3p, 24p. And then 8 times negative 14 is negative 112. So we have the variable on each side. On the left side, you have 24p. On the right side, you have 24p. You have the exact same amount of the variable on each side of the equation. This is the first time we ran across this. So if I want to get the variable to one side of the equation, on the right side, there's 24p. 24p is actually being added to negative 112. Again, there's no sign in front of the 24p. It's a positive. So if I really wanted to, I could put a plus there. So the correct inverse operation is to subtract 24p from each side of the equation. On the left side, when I subtract 24p, the variable completely goes away. 24p minus 24p is 0. So those cancel each other out. Same thing on the right side as well. So on the left side, we have 72, just 72. Again, no more p's. And then on the right side, we just have negative 112. So this is kind of a special case. The variable completely goes away. And then what we're left with is an untrue statement. 72 is definitely not equal to negative 112. If we're left with an untrue statement, then our solution, instead of coming up with, in this case, like p is equal to some specific number, basically nothing works. So no solutions. Or sometimes you can also say no real solutions. But no solutions means no number that you substitute back into the original equation would give you a true statement. So the answer or the solution, which you actually do have to write out, is no solutions. And then that happens when the variable completely goes away and we're left with an untrue statement. So let's take a look at an example, or example number 5, for possibly another special case. Okay, we can't really do anything with the left side right now. On the right side, we could distribute the 8 to each term inside the parentheses. So 8 times 2f on the right side is 16f. And then 8 times 3 is 24. Left side is 16f plus 24. So again, we have the exact same amount of the variable on each side of the equation. If I get rid of the 16f from the right side of the equation, the correct inverse operation is to subtract 16f. So I subtract 16f from each side of the equation. On the left side, we have 24, since 16f minus 16f is 0. On the right side, we also have 24. So again, we have a special case because the variable completely goes away, but instead of your solution being no solutions, since this statement is always true, 24 is equal to 24, definitely true. Something equal to itself, something is always equal to itself. That's supposed to be, say, true. So then our solution is either infinitely many solutions. You could also say identity. Either would be correct. So what infinite solutions means is an infinite number of numbers, or in other words, an endless number of numbers that you could substitute back into your original equation would give you a true statement. For example, if I just substituted in 1, 16 times 1 is 16, and then plus 24 is 40. So left side is equal to 40. I'll write that down so I can remember that in a minute here. And then on the right side, if I substitute in 1, 2 times 1 is 2, plus 3 is 5, and then 5 times 8, 40. So 1 works. If I substitute in 0, I'm trying to pick easy numbers to substitute in, 16 times 0, 0 plus 24 is 24. 2 times 0 is 0, plus 3 is 3, times 8 is 24. 0 works. 0.5 or 1/2 would work. -1 would work. That's why there's an infinite number of solutions, okay? Not just one solution for this equation, okay? But those are special cases, either no solutions or infinite solutions, infinitely many solutions occur when the variable completely goes away. Okay, don't think that for every single equation that we have, there's either going to be no solutions or infinite solutions. Before these two examples here, we've had one solution that basically is our solution for the equation. But look for these special cases on certain equations, not all the equations.